The surface of the Earth appears calm when seen from above, as if it were a motionless body slowly spinning in the void. But beneath that fragile skin, the planet pulses, trembles, and rebuilds itself without rest. The crust we walk upon is only a thin shell, floating on an ocean of molten rock. And this solid layer moves, breaks, sinks, and rises again, like a lung breathing for billions of years. Every second, mountains rise, oceans expand, and entire continents drift in opposite directions, driven by an invisible force that comes from the depths. Nothing here is permanent. Nothing man has built will resist time. The Earth is, and has always been, a living machine designed to destroy and be reborn. What we call stability is merely a moment of silence between two geological catastrophes. The nature of the planet is transformation, and every era carries within it the seed of its own ruin. The ground beneath our feet is recycled in an endless cycle of creation and annihilation, powered by heat, pressure, and time. The same soil that today supports forests and cities was once the deep ocean, once magma, once ice. Everything that exists on the Earth's surface is the result of processes that devour what came before. The planet destroys itself to remain alive, erasing its marks and recreating itself from its own ashes. For billions of years, the internal heat of the Earth, generated by the violent formation of the planet and by the disintegration of radioactive elements in its core, has fueled this machine of renewal. The molten metallic core spins in constant convection, slowly moving the rocky mantle, and it is this deep dance that pushes continents, opens oceans, and sculpts mountains. The planet's interior is a heart that has never stopped beating, and this slow motion, almost imperceptible on a human scale, sustains the dynamic balance that allows life to exist. Without it, the climate would collapse, the atmosphere would stagnate, and the planet would become a dead world. On a human scale, we live as if the world were solid and unchanging, but geological time laughs at this illusion. 1,000,000 years for the Earth is just the blink of an eye. Entire mountains rise and fall in that span. Rivers change course, deserts become seas, and seas turn back into deserts. Every grain of sand on a beach carries a story of destruction. It was stone, it was mountain, it was abyss, and one day it will be all that again. The Earth does not know the word permanence, only transformation. The planet is a patient sculptor, and its masterpiece is the very cycle of change. Humans appeared for only an instant on the cosmic clock, and yet they believe they rule the world. But for the planet, our civilization is nothing more than a brief dust upon a moving rock. Roads, buildings, and borders will vanish as if they never existed. The Earth does not keep human memories, it keeps eras. What we call distant past is, for her, continuous present. The same processes that shaped the first continents are still at work now, invisible and slow, preparing the next global reconfiguration. We live upon a giant that sleeps, but its sleep is restless. If we could watch the Earth through the accelerated lens of geological time, we would see something hypnotic and chaotic at once. Continents sliding like fragments of crust over a boiling cauldron, oceans opening into glowing fissures, mountains growing and collapsing like petrified waves, glaciers covering everything in white and then melting into blue seas. We would see volcanoes spitting life and death, meteors streaking through the sky, and rearranging entire ecosystems. With each destruction, new forms would emerge from the ruins. With each birth, a new end would be sown. That is how the planet breathes. That is how it stays alive. Geology is the language of the Earth's memory. Each layer of rock is a sentence written in fire, ice, and pressure. Every mineral carries the testimony of an ancient catastrophe. When we study the planet, we are not looking into the past. We are observing the present, stretched into infinity. Every mountain is a frozen instant in the flow of time. Every volcano is an open wound in the planet's skin. Every ocean is a mirror reflecting the breath of a world that never fully sleeps. The Earth destroys itself because it must reinvent itself. When its interior boils and the ground cracks, the planet is merely redistributing energy, balancing itself, rebuilding itself. Destruction is the purification mechanism that maintains order within chaos. What seems like catastrophe to us is simply maintenance to her. The volcano that destroys a city fertilizes the soil for millennia. The earthquake that devastates a coast creates a new mountain range. The planet does not distinguish between good and evil. only movement and stillness, life and dormancy. And as long as there is heat in its core, the Earth will continue to pulse. That is why the planet does not need us, but we need it. We depend on its instability to exist. Without the movement of plates, without the carbon cycle, without the volcanoes that release gases, the climate would collapse and life would cease. It is chaos that ensures balance. The Earth is a geological organism, and we are merely one of its temporary expressions, a part that breathes with it, but will be replaced when the next cycle begins. In the deep silence beneath our feet lies a world we never see, yet it decides the fate of the surface. The interior of the Earth is a heart in constant combustion, pulsing for more than 4 billion years. An ocean of molten, dense and incandescent metal spins in overlapping layers, transferring heat, energy and motion. This invisible heart sustains the magnetic field, moves the continents, shapes mountains and defines the climate. Without it, the planet would be nothing more than a cold sphere covered in dust, without seas, without air, without life. Everything that exists above depends on what happens below. At the center of the planet lies a solid sphere of iron and nickel, compressed at temperatures above 6,000 degrees Celsius, as hot as the surface of the sun. Around it flows a layer of liquid metal in constant rotation, the outer core acting as a natural dynamo. The motion of this metallic ocean generates Earth's magnetic field, an invisible protective bubble that deflects deadly solar and cosmic radiation. Without this shield, the atmosphere would be slowly stripped away into space, and the Earth would become a barren rock, like Mars. Life exists because the inner core has never rested. Above it, the mantle stretches almost 3,000 kilometers deep. It is neither solid nor liquid, but something between the two, a hot plastic mass that slowly flows like wax under pressure. Convection currents within this mantle carry heat from the interior to the crust, moving tectonic plates like immense geological conveyor belts. The motion is so slow it can barely be perceived, yet it is irresistible on the scale of millions of years. These currents are the planet's bloodstream, carrying energy from the depths to the surface of the world. When the heat from the core finds weaknesses in the crust, it surges upward violently, creating volcanoes and fissures that tear open the ground. What we call an eruption is merely the planet exhaling. The escaping magma carries with it new minerals, ancient gases, and the material that will form the fertile soils of tomorrow. The volcano destroys, but it also creates. It is the Earth's warm breath, shaping the future from the ashes of the present. And even after billions of years of activity, this inner fire has not gone out. The heat that keeps this engine running comes from two sources: the energy left from the planet's violent birth and the radioactive decay of elements like uranium, thorium, and potassium in the inner rocks. Every second, these particles release enough heat to melt the base of the crust and keep the mantle flowing. This silent process ensures the continuous renewal of the surface. When a plate bends and plunges into the depths, it is slowly recycled by heat, later returning as new crust at ocean ridges. The Earth literally consumes itself to remain alive. This geological engine is also responsible for one essential phenomenon: the carbon cycle. Subducted rocks release carbon dioxide into magma chambers, which is expelled by volcanoes and returned to the atmosphere. Over time, this gas dissolves in rain, reacts with rocks, is carried by rivers and returns to the oceans, where it is trapped again in sediments. It is a closed, self-regulating cycle. If the Earth's interior were to cool and stop, the global climate would collapse and life would vanish. The magnetic field generated by the metallic core not only protects, but also guides. It creates the northern and southern auroras, the visible result of solar particles colliding with the upper atmosphere. They are luminous signs that the heart of the planet still beats. As long as auroras dance in the sky, it means the inner fire still breathes. When they disappear, it will be the sign that the Earth is dying within. On a cosmic scale, the Earth is one of the few known worlds whose internal heat still shapes its exterior. The Moon, for example, has long lost its fire. Mars stopped moving inside ages ago and became a cold, silent desert. The difference between a dead planet and a living one is the heart that warms it. The Earth remains alive because it still burns within. This subterranean flame is also what keeps geological time turning. Without it, there would be no new mountains, no earthquakes, no volcanoes, no renewal of ecosystems. there would only be stagnation. Life flourishes not despite the fire, but because of it. Every tree, every river, every living being that breathes now exists, because beneath our feet there is an ocean of liquid metal spinning in silence, feeding the machine of creation. Beneath the ground we believe to be solid, the earth is in constant war with itself. The crust, that thin layer on which we raise cities and dreams, is made of immense blocks of rock, the tectonic plates that float on top of the moving mantle. They collide, pull apart, bend and destroy themselves in an eternal cycle of reconstruction. It is a slow and brutal game, invisible on the human scale, but so powerful that it redraws the map of the planet across ages. Tectonism is the blood of the planet in motion. It is the process that renews the face of the earth and guarantees that nothing remains the same for long. Imagine the crust as cracked skin stretched over an incandescent body. Where the internal heat rises, the skin tears. Where the cold accumulates, it contracts and breaks. Oceanic rifts are the planet's open scars, places where magma rises and creates new crust, slowly pushing the continents in opposite directions. In the subduction zones, one plate dives beneath another, sinking back into the interior of the earth and melting once again. It is a perfect cycle of birth and destruction, so balanced that the amount of crust created and consumed remains almost constant. Nothing is wasted, nothing is eternal. The boundaries between plates are living borders of energy. Where two plates collide, mountains are born. Where they separate, seas emerge. Where they slide past one another, friction generates earthquakes capable of shaking entire civilizations. The planet appears calm, but beneath the surface there is a constant sound of pressure and grinding. Every continent is a stone raft drifting on an ocean of fire, and when two of these rafts collide, the earth groans, raises mountains and opens deep wounds. That is how the largest mountain chains in the world were born. When the Indian plate collided with the Eurasian plate tens of millions of years ago, the rocks folded and pushed over each other, forming the Himalayas, a colossal scar that is still growing a few millimeters per year. The same is happening in the Andes, the result of the impact between the Pacific Oceanic plate and the South American continental plate. Every mountain range is the record of a slow, continuous, and inevitable impact. But tectonism is not only destruction, it is also creation. The mid-ocean ridges, immense underwater mountain chains, are factories of new seafloor. Magma rises through the fractures, cools on contact with the water, and becomes new crust. From these glowing lines, the floors of the oceans are constantly renewed. The Atlantic Ocean, for example, grows every year, millimeter by millimeter, as the Americas move away from Africa. This separation, almost imperceptible, has already changed global climate, marine currents, and the distribution of species countless times. This continuous motion ensures that nothing on the Earth's surface remains the same. The continents unite and split apart, like pieces of a puzzle that never ends. Oceans are born and disappear. Mountains rise and are eroded away. Tectonism is responsible for shaping the stage on which life performs. Without it, the planet would be a motionless desert. Without mountains, without rivers, without diversity of environments. Biological evolution itself depended on this relentless motion, which creates and destroys habitats, forcing life to adapt or vanish. Tectonic faults are the places where the crust reveals its fragility. They store energy for centuries, and then suddenly release it all in a matter of seconds, causing devastating earthquakes. These ruptures are reminders that the Earth is alive, breathing beneath our feet. What we experience as tragedy is, for the planet, only a natural adjustment toward balance. The same energy that moves the plates also sustains the magnetic field, volcanism, and even the carbon cycle that keeps the climate habitable. Everything is connected. In some regions, tectonism creates geological traps of rare beauty. In the Rift Valley in eastern Africa, the crust is being slowly torn apart, and a new ocean will be born there in millions of years. The deep fractures that cut through the ground are gateways to the interior of the Earth, where gases rise, lakes form, and new species emerge in isolated ecosystems. The planet is in a state of continuous birth, and every fracture announces a new form of world. There is a violent poetry in this movement. The Earth does not know rest, only change. Its plates move so slowly that they seem motionless, But on the geological scale, they are solid waves reshaping everything that exists. Every centimeter that a plate advances or retreats is a note in the symphony of time, and we, fragile and brief, walk over that music without noticing it. When an earthquake happens, the planet is only sighing. When a volcano erupts, it is only breathing. Tectonism is the breathing of the world, the alternation between destruction and rebirth. Nothing that exists now will remain forever. The continent we inhabit will one day sink or tear apart, and a new one will rise in its place. The planet we step on today is not the same as yesterday, and it will not be the same tomorrow. The map of the Earth has never been fixed. The world we know today is only a fleeting photograph of a planet in constant rearrangement. Hundreds of millions of years ago, the continents were not where they are now. They formed a single gigantic block of land, a supercontinent. This immense continental mass has come together and broken apart several times throughout geological history, in a hypnotic cycle of construction and destruction that shaped oceans, climates, and forms of life. Every time the Earth splits, a new world is born. Every time it reunites, it erases all that came before. The first great supercontinent known is called Columbia, formed between 2 billion and 150 million and 1 billion and 800 million years ago. It was the first act of a cycle that would repeat forever. Then came Rodinia, once again merging the land masses and concentrating almost all the planet's exposed ground into a single dry and windy region. Millions of years later, Rodinia fragmented and gave rise to another giant, Pannotia. But the most famous of them all, and the closest to us in time, was Pangaea, the supercontinent that dominated the planet between 330 million and 200 million years ago. Imagine a world where all the continents we know, America, Europe, Africa, Asia, Antarctica, and Oceania, were joined in one colossal mass, surrounded by an immense ocean called Panthalassa. Inside this supercontinent, the climate was extreme. Vast deserts burned under the heat, while the coastal edges were battered by violent oceanic storms. This enormous and unstable environment shaped life in unexpected ways. The concentration of land altered winds, currents, and rainfall, creating regions of desolation and others of abundance. When Pangaea began to break apart, life spread in all directions, occupying new spaces and diversifying. The mechanism that creates and destroys supercontinents is the same one that moves the tectonic plates. As the planet's inner heat rises and accumulates beneath the continental crusts, internal forces push the land masses together. Over time, the energy redistributes and the balance reverses. The continents begin to drift apart again, opening oceans and reshaping the planet. This cycle is known as the supercycle, and it takes hundreds of millions of years to complete. The Earth lives in an eternal rhythm of union and separation, of concentration and dispersion. Each formation of a supercontinent triggers a chain of climatic and biological transformations. When all the land is gathered together, the continental interior becomes isolated from the ocean's humidity, and deserts spread widely. The climate becomes severe, the rains scarce, and the temperatures extreme. When the lands break apart, new oceans appear, bringing humidity and life. Ocean currents establish themselves, regulating the climate and distributing heat. This geological rhythm, invisible to the human eye, is the metronome that dictates the periods of stability and collapse of the biosphere. The supercontinents also played a decisive role in mass extinctions. When Pangaea formed, for instance, the global rearrangement of the crust provoked intense volcanic activity, releasing enormous quantities of gases into the atmosphere and altering the chemical balance of the oceans. The result was an environmental collapse that led to the disappearance of countless species. Later, when Pangaea began to fragment, the planet went through another period of chaos, but this time, chaos brought rebirth. The new coasts, islands, and seas created varied ecological niches and allowed new forms of life to emerge. The idea that continents move may seem obvious today, but it was a recent scientific revolution. At the beginning of the 20th century, the geophysicist Alfred Wegener proposed that the continents had once been joined and later drifted apart. At the time, the idea was rejected. Only decades later, with the advancement of modern geology and the mapping of the ocean floor, was it confirmed that he was right. The continents truly drift over the mantle. driven by invisible forces from the depths. The Earth is a moving puzzle, and its pieces are always changing places. The current configuration of the planet is only an intermediate stage. The Atlantic Ocean continues to expand. Africa is slowly approaching Europe, and the Pacific, the largest ocean today, is shrinking with each passing century. One day, all continents will once again come together. Geological models suggest that within 200 to 300 million years, a new supercontinent will emerge. Some call it Amasia, others Pangaea Proxima. Regardless of the name, the outcome will be the same: new mountains, closed oceans, extreme climates, and the restart of the entire cycle. When that happens, the map of the Earth will be unrecognizable. What is now ocean may become an arid plateau, and what is now mountain may sink beneath the waves. The planet will erase its tracks once again, as it always has. With each new supercontinent, geological history reorganizes itself, and life must begin anew. Destruction is not the end, it is the mechanism of renewal. The Earth gathers everything, breaks everything apart, and repeats like a slow breath between creation and forgetting. The history of the Earth is marked by rebirths, but for each new chapter to begin, another one has to end. And the planet has no mercy when it turns its pages. In 5 crucial moments, life was almost completely erased from the surface. These are the events we call mass extinctions, periods when the planet pressed its own reset button, eliminating most existing species and opening space for new forms to dominate the world. With each one, balance was destroyed and then rebuilt, as if the Earth needed to reinvent itself from time to time. The first great extinction happened at the end of the Ordovician period, around 444 million years ago. At that time, life flourished in shallow seas, dominated by trilobites, primitive corals, and marine mollusks. But the planet entered a sudden climatic collapse. A global glaciation froze the oceans and lowered sea levels, destroying entire habitats. When the ice melted, the sea rose again, altering the chemistry of the water and suffocating the surviving species. In just a few 100,000 years, a geological blink, about 85% of all marine life had disappeared. The second extinction came at the end of the Devonian period, between 375 million and 360 million years ago. The seas turned poisonous, saturated with nutrients carried from continental erosion and with blooms of algae that consumed the oxygen. Meanwhile, volcanoes and cosmic impacts made the imbalance worse. 90% of reef species and a large part of the primitive fish vanished. But from the ashes of that collapse emerged the first vertebrates able to live on land, which would begin to conquer the world outside the water. The third and most devastating of all was the end Permian extinction, about 252 million years ago. No other event in the planet's history caused so much destruction. It is estimated that 95% of all marine species and 70% of all land species disappeared. The Earth almost literally died. Giant eruptions in the region that corresponds today to Siberia released trillions of tons of carbon dioxide and methane, triggering a catastrophic greenhouse effect. The oceans became acidic, the atmosphere turned toxic, and the planet entered thermal collapse. For millions of years, the Earth was a suffocating and silent desert. When life finally returned, it was a new world, the world of dominant reptiles, which would later evolve into the dinosaurs. The fourth great extinction, at the end of the Triassic period around 200 million years ago, was once again the result of an internal convulsion of the planet. As the supercontinent Pangaea began to fragment, immense fissures opened, releasing gases and ash on a continental scale. Temperatures swung violently, the oceans became unstable, and food chains collapsed. Nearly 80% of species disappeared, but the Earth once again reinvented itself. With the former competitors gone, the dinosaurs took over the world and began a reign that would last more than 150 million years. The fifth extinction, the most well-known, ended that reign. The impact of an asteroid 66 million years ago turned the planet into an inferno. The object, more than 10 kilometers wide, struck the region that is now the Yucatan Peninsula and released energy equivalent to billions of atomic bombs. The sky caught fire. Giant tsunamis swept across the oceans. Dust and soot blocked sunlight, plunging the world into a night that lasted for months. The extreme cold that followed killed plants, shut down photosynthesis, and collapsed the entire food chain. In a matter of decades, the non-avian dinosaurs were gone, but in the ruins, the mammals, small and discreet until then, found their chance. Life reorganized once again, and history moved in a new direction. These 5 great extinctions were not isolated accidents, but chapters of the same cycle. The Earth has a pattern of destruction and renewal. Each collapse eliminates old forms and creates conditions for new ones to emerge. The planet seems to use catastrophe as an evolutionary tool. Chaos is not the end. It is the seed of another phase. Life is resilient because the planet forces it to be. But there is something unsettling in realizing that the same mechanism is still active. The Earth is still a machine that presses the reset button. Volcanism, warming, climate shifts, and chemical transformations are still happening. The difference now is that a conscious species lives on it, altering the balance with unprecedented speed. The planet has always recovered from its own catastrophes. The question is, will it recover from us? 252 million years ago, the planet went through the darkest moment in all of its history. No event before or after came so close to erasing life completely. It was the end of the Permian period, the moment when the Earth almost truly died. The crust trembled, the sky darkened, the seas boiled, and even the air became poison. With every breath, the planet destroyed itself from within. What remained was a toxic and silent desert. Almost everything that lived, plants, animals, and microorganisms, disappeared. The Earth itself seemed to have given up breathing. What caused such devastation was a sequence of geological cataclysms of unimaginable proportions. In what is now Siberia, the ground opened into giant fissures that spewed lava and gases for millions of years. This region, known as the Siberian Traps, released more than 3 million cubic kilometers of magma, enough to cover all of Brazil with a layer of incandescent rock more than 1 kilometer thick. With every eruption, gases like carbon dioxide, methane, and sulfur dioxide rose into the atmosphere, radically changing the chemistry of the air and the oceans. The climate went mad. The increase in carbon dioxide brutally warmed the planet. Global average temperatures rose by about 10 degrees Celsius in just a few thousand years, a pace so fast that no ecosystem could adapt. The overheated oceans lost oxygen, turning into stagnant, suffocating seas. Anaerobic bacteria thrived in the depths and began to release hydrogen sulfide, a toxic gas that rose to the surface and poisoned everything that breathed. Plants withered, animals suffocated, and life collapsed like a disconnected network. The soil burned. The rain turned acidic. Volcanic ash covered entire continents. The combination of global warming, ocean acidification, and atmospheric poisoning created the perfect scenario for extermination. It is estimated that 95% of marine species and 70% of land species were wiped out. Corals, trilobites, ammonites, and ancient forests vanished. It was as if the Earth itself had decided to erase the past and begin again. Even after the eruptions ended, the planet took millions of years to recover. Ecosystems had collapsed completely, and the process of reconstruction was slow and arduous. In the void left by destruction, new lineages began to appear. Small reptiles, ancestors of the dinosaurs, found space to thrive in an almost uninhabited world. Insects, fungi, and microorganisms were the first to return. The planet, little by little, began to breathe again. The end Permian extinction was the abyss from which life emerged transformed. Modern geological studies reveal rock layers marked by burned carbon, ash, and peaks of heavy metals, direct traces of this catastrophe. In some places, there are records of entire dead seas, black deposits of sediments rich in organic matter that never fully decomposed. These marks are the petrified memory of a world that was almost forgotten. The Earth erased nearly everything, but left a reminder carved into its skin, the warning that destruction is part of the cycle, and that life is only one of the ways through which the planet recreates itself. When balance finally returned, the Earth was different. The climate had changed, the continents were reorganizing, and the surviving species were unlike those that had ruled before. From the few beings that managed to survive the hell of the Permian, new lineages arose that would dominate the next ages. Among them were the archosaurs, which would give rise to the dinosaurs, and the first primitive mammals. The world became the stage of a new era, the Triassic. and nature once again proved that there is no eternal ruin. The great end of the Permian was the deepest scar in the history of the Earth, a wound that never completely healed, but taught the planet to rebuild itself from emptiness. What seemed to be the absolute end was, in truth, the beginning of another journey. Life, reduced to a few threads of resistance, reinvented itself. The planet survived because it knows how to die in order to keep existing. 66 million years ago, the Earth witnessed one of the most violent days since its formation, an instant as brief as the beat of a heart, yet powerful enough to end an entire era. In that moment, a body from space, an asteroid about 10 kilometers wide, crossed the sky at a speed of more than 70,000 kilometers per hour and struck the planet with energy equivalent to billions of atomic bombs. The impact occurred in the region we now know as the Yucatan Peninsula, and within seconds, the world of the dinosaurs came to an end. The collision opened a crater more than 180 kilometers wide and over 20 kilometers deep. The ground melted instantly, and the ocean vaporized in a flash so intense it could have been seen from the other side of the planet. The shock wave raced around the globe in minutes, triggering earthquakes, tsunamis, and secondary eruptions everywhere. The air caught fire. Millions of tons of vaporized rock were hurled into the atmosphere and fell back in flames, turning the sky into a furnace. Surface temperatures soared, and entire forests ignited within hours. But the most devastating blow came afterward. The fine particles thrown high into the atmosphere blocked sunlight, plunging the planet into prolonged darkness. Photosynthesis stopped. Plants died. With them vanished the herbivores, and soon after, the carnivores. A global winter set in, with temperatures dropping to lethal levels. The blue planet became grey, frozen, and silent. For months, perhaps years, the Earth lived under an almost absolute night, lit only by the embers of its own collapse. The dinosaurs, who had ruled for more than 150 million years, perished. Only a few groups of birds and small mammals survived, hidden in burrows, feeding on seeds and remains. The reign of the giants was over, and in their place emerged a new world. The world of the small, the resilient, those who knew how to wait. The Earth had pressed the reset button once again. The consequences of that impact are still etched into the planet's skin. Melted rocks, layers of iridium, a metal rare in the Earth's crust but common in asteroids, and carbonized fossils form a silent record of destruction. The Chicxulub crater, buried beneath layers of sediment, is the geological testimony of the instant when the destiny of life changed forever. It was not merely a physical impact, but a biological and historical one. Life reorganized, the biosphere rewrote itself, and mammals, once shadows in the forests, became the planet's new heirs. What is astonishing is how precisely chance blended with inevitability. If the asteroid had arrived just a few minutes earlier or later, it might have struck elsewhere, in a region poorer in sulfur and carbonates. The atmosphere would not have been so poisoned, and perhaps the dinosaurs would still walk the Earth. But the universe does not know perhaps. It knows consequences, and in that fraction of a second, the course of evolution changed forever. The extreme conditions after the impact forced life to adapt quickly. Mammals, small and discreet, survived because of their flexibility. They could hibernate, live underground, and feed on varied diets. In the millions of years that followed, these survivors diversified, filled the empty niches, and gave rise to new forms. Among them, much later, emerged the human being. We are, in a way, direct descendants of a catastrophe. We exist because one day the sky fell. The Chicxulub impact was not an error, but part of the same cycle that governs the entire planet. The universe creates by destroying. The Earth has always rebuilt itself from the ruins of what came before. Every catastrophe leaves space for something new to bloom. And as long as there is movement, heat, and time, this process will never end. Destruction is merely the beginning in disguise. At the heart of the Earth, where heat is constant and pressure is nearly infinite, rock behaves like a furious liquid, and the planet endlessly seeks a way to release its accumulated energy. The result is volcanoes, living chimneys that connect the incandescent interior to the surface. They are the means by which the planet breathes, exhales, and is reborn. They are at once creators and destroyers, sculptors of the world and messengers of chaos. No other phenomenon so perfectly expresses the ambiguous character of Earth as volcanism, the force that kills and, moments later, fertilizes what it destroyed. More than 4 billion years ago, When the planet was still young, volcanoes covered its entire surface. The air was toxic, and the sky glowed red with ash and gas. Yet it was this violence that formed the primitive atmosphere and brought part of the water that now covers the Earth. Each explosion hurled vapor, carbon dioxide, and sulfur high into the sky, transforming incandescent chaos into conditions suitable for the chemistry of life. In other words, the same force that destroys everything around it also created the environment that allows us to breathe. Volcanoes remain the Earth's escape valves. When magma rises, it carries fragments of the planet's deep history, minerals formed millions of years ago, gases trapped since the birth of the core, and particles that once lay at the bottom of ancient oceans, returning to light after ages of darkness. An eruption is, in truth, a revelation, a reminder that the Earth's interior is still alive, and that everything we see is only a thin, temporary crust above eternal fire. But volcanism is also a reminder that the planet can be lethal. Throughout history, colossal eruptions have changed the course of the Earth. The explosion of Mount Toba, 74,000 years ago, launched so much material into the sky that it created a volcanic winter lasting for years, drastically cooling the planet and affecting early human populations. The eruption of Mount Tambora in 1815 was so intense that it altered the climate of the northern hemisphere and caused the so-called year without a summer, bringing famine and despair. And the eruptions of the Siberian traps at the end of the Permian period nearly wiped out all life. These forces do not belong only to the distant past. Every second, hundreds of volcanoes release gases, dust and magma, reshaping the surface of the Earth. Some are discreet, breathing slowly through oceanic fissures. Others are explosive and violent, capable of altering the planet's climate in a matter of days. The global climate balance depends in part on this continuous release of gases, which keeps the carbon cycle active and prevents the Earth from freezing eternally. Without volcanism, the planet would be static, without renewal, without breath. Volcanic soil is another fascinating paradox. After destruction comes fertility. The ash, rich in minerals, turns barren land into fertile ground, giving rise to lush ecosystems. Entire tropical forests grow on what was once a river of lava. Ancient peoples learned this and built civilizations on volcanic slopes, accepting the risk in exchange for abundance. They understood that living near a volcano meant coexisting with the very nature of Earth, unpredictable, generous, and dangerous. Behind the visual spectacle of eruptions lies a dance of deep forces. Magma forms when part of the mantle melts due to heat, pressure, and chemical composition. It rises because it is less dense than the solid rock around it. When it finds fractures, it seeks a way out. What happens next depends on its viscosity, gas content, and accumulated pressure. Sometimes it flows in slow red rivers, other times it explodes violently, sending columns of ash into the stratosphere. Each volcano is a portrait of the planet's geological soul. The Earth's magnetic field, powered by the movement of its core, and volcanism, driven by internal heat, are two faces of the same engine. When the fire within the Earth finally ceases, both will vanish, and the planet will die from within. Volcanoes are therefore the most visible sign that the Earth is still alive. Each eruption is a heartbeat of the world, a reminder that the planet's heart still beats. Ultimately, volcanism is a metaphor for existence itself. Nothing is born without destruction, and nothing is reborn without loss. Fire consumes, but what it leaves behind is the raw material of life. We are all children of volcanism, made of minerals that once flowed molten within the planet. The ground beneath our feet is only cooled lava, the residue of ancient storms of fire. The Earth created us with the same hands that at any moment could erase us. There was a time when the entire planet was covered in ice, not just the poles or the mountains, but every continent, every ocean, every plain. A white, silent world where the sun reflected off frozen surfaces and the atmosphere remained cold and still. This extreme phase, known as Snowball Earth, was one of the most dramatic moments in the planet's history, an era when life stood on the edge of disappearance and yet still found a way to endure. The ice was not only destruction, it was also the beginning of a transformation that would change everything. Scientists believe that this global glaciation took place between 725 million and 635 million years ago, during the Cryogenian period. The exact causes are still debated, but the evidence points to a combination of catastrophic factors. Volcanoes went quiet, reducing the release of carbon dioxide, while the weathering of newly formed mountains pulled this gas out of the atmosphere, weakening the natural greenhouse effect. The result was a runaway cooling that spread in a chain reaction. Snow reflected more and more sunlight back into space, preventing warming. The planet entered a self-sustaining spiral of ice. The oceans froze to depths of hundreds of meters, and light could no longer penetrate the water. Ocean currents stopped, the atmosphere became dry and thin, and even carbon dioxide began to solidify at the poles. Shallow seas and early seafloor ecosystems, which at the time were the main environments for life, were sealed beneath a vast shell of ice. The Earth seemed to have become a dead world, motionless, a crystalline globe drifting in silence through space. But even in this frozen hell, life persisted. Tiny microorganisms survived in unlikely refuges, volcanic fissures, pockets of liquid water trapped beneath the ice, and thermal zones at the bottom of the sea. These refugees, fed by heat and minerals, kept alive the biological spark that would later reignite the planet's diversity. Life, even reduced to almost nothing, refused to disappear, and it was in this extreme isolation that biology reinvented itself. Many scientists believe that the complexity of eukaryotic cells, the cells that make up all multicellular organisms, may have evolved during or shortly after this period of total freezing. The thaw was slow and violent. The continuous release of volcanic gases, especially carbon dioxide, created an intense greenhouse effect. When the ice finally began to melt, the planet went from eternal winter to sudden overheating. Water vapor flooded the atmosphere. Colossal storms swept across the continents, and entire oceans boiled with chemical reactions. Minerals dissolved in the meltwater delivered abundant nutrients, triggering a biological explosion without precedent. The Earth was reborn, and life expanded with a force it would never experience again. The rocks that hold the memory of this event are silent testimonies of a planet that nearly died frozen. Layers of glacial sediments are found in places that today lie near the equator, clear proof that ice covered the entire planet. On top of those layers are carbonate deposits formed right after the thaw, a direct result of the abrupt return of heat and rain. These are geological scars of a global trauma, recorded in the Earth's crust. The Snowball Earth episode was more than a climate catastrophe. It was an evolutionary reset. By freezing itself, the planet erased almost all of its old ecosystems and forced life to restart in new forms. It was after this event that the first complex multicellular organisms appeared. In other words, without a frozen Earth, there might never have been animals, plants, or human beings. The ice that nearly killed the planet also prepared it to flourish again. This story reveals the true pattern of Earth: alternating extremes, destructions that prepare the ground for creation. The planet does not seek balance. It swings between fire and ice, between suffocating heat and absolute cold. What looks like collapse is, in truth, an adjustment. The Earth sheds its skin, and life adapts to the new shape. In the end, the ice was not an enemy, but a necessary pause in the planet's rhythm, a silence before the next explosion of life. There is an invisible thread connecting the fire within the Earth, the air we breathe, and the balance that allows life to flourish, the Markabun cycle, Daikyu. It is the mechanism that regulates the planet's climate, the deep respiration of the Earth on the scale of millions of years. Without it, the world would have frozen or burned countless times. With it, global temperature oscillates within limits that allow life to persist. It is the most complex and delicate system that exists, a circuit linking rock, ocean, atmosphere, and living beings, in which each part depends on the others to continue existing. Everything begins with carbon dioxide, the gas that acts like a blanket around the planet. It traps part of the sun's heat, preventing the Earth from becoming a frozen desert. Some of this gas rises from the depths, expelled by volcanoes and oceanic fissures. The rest is released by organisms and decomposers that return to the air the carbon once locked within dead bodies. When there is too much carbon dioxide, the planet warms. When there is too little, the cold advances. The Earth regulates this balance with blind precision through slow and relentless processes. Mountains are one of the planet's great mineral lungs. As rain falls upon them, the carbon dioxide in the atmosphere dissolves in water and reacts with rocks, chemically wearing them down. This process, known as weathering, transforms the gas into ions that are carried by rivers to the sea. There, they combine with calcium to form carbonates, the same minerals that make up corals, shells, and marine sediments. When these organisms die, their remains accumulate on the seafloor and, over time, form layers of limestone. Thus, the carbon that once floated in the air becomes imprisoned underground, where it will remain for millions of years. But nothing on Earth is permanent. The tectonic plates, in their ceaseless motion, push the ocean floor deep into subduction zones. There, the extreme heat melts part of the rock, releasing carbon dioxide once more. It rises with the magma and returns to the atmosphere through volcanoes. What was stone becomes gas. What was buried in the depths returns to the sky. It is a closed and eternal cycle. Carbon is born from fire, turns into rock, and returns as air. This process is so slow that it takes millions of years to complete a single turn. Yet it is what keeps the planet habitable. When mountains rise, weathering intensifies and removes more carbon dioxide from the air, cooling the climate. When tectonic activity slows and volcanism increases, the gas builds up again, and the planet warms. It is a self-regulating mechanism that prevents permanent extremes. The Earth swings between cold and heat, but never long enough to lose life. It adjusts, as if it had a kind of unconscious wisdom. Life, in turn, has become an essential part of this cycle. Plants, through photosynthesis, remove carbon dioxide from the air and release oxygen, balancing the composition of the atmosphere. The oceans absorb vast amounts of the gas, serving as reservoirs that cushion climatic variations. Plankton, invisible to the eye, is one of the greatest agents of the planet's climate. Every organism, no matter how small, takes part in this dance. Carbon circulates among all living things, and when we die, we return it to the soil, completing the cycle. Yet the balance is fragile. Geological history shows that even small alterations in this cycle can bring catastrophic consequences. When the volcanism of the Siberian traps flooded the atmosphere with carbon dioxide, the planet entered a thermal collapse. When weathering became too intense, the Earth plunged into ages of ice. Now, for the first time, a conscious species interferes in this system. In just a few centuries, we have burned the carbon that took millions of years to be trapped in coal, oil, and gas. We are releasing the fire of the past at an unprecedented speed, and the planet is beginning to respond. Even so, the carbon cycle reveals the wisdom of the Earth. It is the reminder that everything we breathe was once rock, and everything solid will one day return to the air. We are part of this flow, and our lives are only temporary expressions of this movement. Each breath is a loan the planet grants us, the same air that has passed through oceans, mountains, forests, and volcanoes. The Earth keeps nothing for itself. It simply recycles everything, without haste, without end. The oceans are the living scars of the planet. They are born, they grow, and they disappear like wounds that open and close slowly over millions of years. At first glance, they seem eternal, but on Earth's timescale, no sea lasts forever. What we now call the Atlantic, the Pacific, or the Indian Ocean are only temporary phases in a geological cycle that never stops. Oceanic crust is constantly being created in the depths and devoured at the margins. The ocean is at the same time birth and death. It all begins at the mid-ocean ridges, immense underwater mountain chains that snake across the seafloor like glowing seams. There the hot mantle rises, magma spills out, and solidifies into new crust. It is the point of creation, where the Earth remakes its skin. Ocean water seeps into the freshly formed rock and reacts with its minerals, becoming enriched with iron, sulfur, and silica. Then, superheated currents rise through hydrothermal vents, hosting colonies of life that do not depend on sunlight. It is in these places that the planet is still manufacturing new crust, and perhaps where life itself first began. As the newborn crust drifts away from the ridge, it cools, becomes denser, and slowly begins to sink. Millions of years later, somewhere else on the planet, that same crust will be swallowed back into the interior at subduction zones. There, one plate plunges beneath another, and the oceanic rock is slowly melted, releasing gases and minerals, Part of that material returns to the surface in the form of volcanoes, and the cycle begins again. With every new generation of crust that is born, an older one is destroyed. This is how the planet maintains its balance, creating and erasing at the same time. This continuous motion also reshapes the world map. Oceans open and close to a slow, inevitable rhythm. The Atlantic, for example, has been widening ever since the Americas split from Africa about 180 million years ago. The Pacific, the largest of all, is shrinking. Its margins are ringed by a chain of volcanoes and earthquakes known as the Ring of Fire, where the crust is constantly pushed back into the mantle. One day it will disappear completely, and the continents will come together again into a new supercontinent. The Earth has done this countless times and will continue to do so. When an ocean is born, it changes the entire climate of the planet. Newly formed marine currents redistribute heat, moisture, and nutrients, creating ecosystems and shaping weather. When an ocean dies, that balance unravels. The destruction of ancient seas and the rise of new ones alter winds, temperatures, and biological flows. The planet is a dynamic being, and its oceans are the blood running through its open veins. Geological records reveal oceans that once existed and then vanished entirely. The Iapetus Ocean, ancestor of the Atlantic, closed more than 400 million years ago when continents collided to form Laurussia. Panthalassa, the great ocean that surrounded the supercontinent Pangaea, disappeared about 200 million years ago, giving rise to the modern seas. Each ocean that dies leaves behind mountains, plateaus, and coral fossils, quiet reminders of a world that no longer exists. The seafloor is the oldest archive of Earth's story, and yet also the most short-lived. No oceanic rock is older than 200 million years, because everything before that has already been recycled. In contrast, there are continental rocks more than 4 billion years old. That means that while continents hold memory, oceans live in the present. They are the Earth's now, ephemeral, mobile, renewable. This constant renewal is what prevents the planet from going into thermal collapse. By creating and destroying crust, the Earth regulates the release of heat and recycles chemical elements essential to life. The reactions that occur at ridges and subduction zones control the composition of the atmosphere, the salinity of the oceans, and even climate stability. The motion of deep water, guided by this engine, redistributes nutrients and energy. Nothing is static, not even the seemingly calm sea. When we look at the ocean, we see only the surface, but beneath it there is a machine that never stops. The ocean is the living border between the inside and the outside of the planet. It is the mirror where fire and ice meet. Every wave washing onto the shore is a reminder that the Earth is still breathing, that its heart is still beating beneath the crust, and that nothing, not even the ocean, is eternal. Mountains are the monuments of the Earth, symbols of grandeur, permanence, and strength. Yet on a geological scale, even they are fleeting. Every peak, every range, and every valley is merely a phase in a slow and inevitable cycle of construction and ruin. Mountains are born from the collision of continents, rising like wounds torn from the ground, enduring for a few million years, and then beginning to die, worn away by rain, wind, and time. In geology, everything that rises is destined to turn to dust. The birth of a mountain begins in the depths. When two tectonic plates collide, neither wants to yield. Rock, compressed by unimaginable forces, folds, fractures, and stacks upon itself, forming walls of stone that stretch across continents. It is the planet pressing against itself, redistributing energy and matter on a scale far beyond human perception. The impact is so slow that over an entire lifetime, a mountain might rise only a few centimeters, but over centuries that motion accumulates to create ranges that touch the sky. The Himalayas, for instance, were born from the collision between India and Eurasia, a meeting that began about 50 million years ago and still continues. The mountains in this region rise at a rate of roughly 5 millimeters per year, imperceptible to us, but monumental to the Earth. Every earthquake in Nepal or Tibet is a reminder that the planet is still sculpting its own face. The same process shaped the Andes, the Alps, and the Rocky Mountains. What we see today is just a snapshot in time, but the same energy that creates also destroys. As soon as a mountain is born, time begins to wear it down. Gravity pulls. Rain dissolves, wind carves, ice cracks. Fragments break loose, turning into sand and mud that flow through rivers and settle on distant plains. What was once the roof of the world becomes a tiny grain of sediment. Over the ages, these sediments harden into new rocks, and when the planet collides again, they will rise as new mountains. It is a perfect cycle, to be born, to die, and to rise again elsewhere. Erosion is the silent sculptor of the earth. It does not merely destroy, it shapes. The sinuous lines of valleys, the sharp peaks, the gentle slopes of hills are all the work of this patient force. Destruction is the hand that molds beauty. Each mountain carries the balance between the inner violence that lifts it and the outer tenderness that consumes it. In the end, everything solid becomes dust, and every dust grain will one day be solid again. The story of mountains is also the story of continents. Ancient ranges, long worn away, reveal the wreckage of forgotten collisions. The Serra do Espinhaço, the Canadian Shield, the Greenland Massif, all are ghosts of mountains that were once giants. Today, only their foundations remain, softened by time. They are the exposed bones of the earth, silent witnesses of a past of power and destruction. Mountains also shape climate and life. They force moist air upward, cooling it and causing rain, while creating deserts on the other side. They are barriers that mold ecosystems, deflect winds, and divide species. Without them, the biosphere would be uniform and monotonous. Each mountain range is a natural laboratory of adaptation. The more they rise and erode, the more life must change alongside them. Yet, no matter how imposing they seem, mountains have an expiration date. The great ranges that exist today will someday be plains, and new peaks will rise in places that are now oceans. When Africa collides with Europe, the seas will close, and a new chain of mountains will rise between them. It is the planet repeating its art, reshaping itself on scales the human mind cannot conceive. The dust carried by the wind, the grain of sand rolling down a river, the sediment resting at the bottom of the sea, all were once part of mountains, and one day they will be again. The planet recycles even what seems indestructible. Stone is merely a temporary form of time. Mountains teach us that nothing is permanent, not even that which seems to touch the sky. Life on Earth has never evolved in peace. Its greatest teacher has always been chaos. Every global catastrophe, every abrupt climate change, every environmental collapse has served as a trigger for biological reinvention. When the planet destroys itself, life remakes itself. When conditions change, organisms change with them. Evolutionary history is not a straight line of progress, but a sequence of falls and rebirths. It is the planet's own response to its crises. A mass extinction is not merely the end of species, but the starting point of others. After each catastrophe, the world opens again to the survivors. When most species vanish, what remains is space, food, and opportunity. Lineages that were once small and insignificant take the place of the former dominants. This is how life reinvents itself. With every destruction, it reorganizes. After the great end of the Permian, for example, the reptiles that had survived in the shadows of swamps began to expand, and in just a few million years, the planet would be ruled by dinosaurs. The catastrophe that killed almost everything was the same event that made the reign of giants possible. The same story repeated itself after the impact of the Chicxulub asteroid. The world of the dinosaurs came to an end, and mammals, small, nocturnal, and discreet, found an empty planet, ready to be conquered. They evolved in an explosion of forms. Some returned to the water, others took to the air, others developed intelligence. We are direct descendants of that post-chaos expansion. We exist because the world collapsed before us. Destruction, paradoxically, is the engine of creation. In every era, Earth has redefined life according to its own rules. When volcanoes darkened the sky, only the beings that could withstand cold and hunger survived. When ice covered the planet, survival demanded adaptation to extreme environments. When the oceans boiled, only organisms that tolerated acidity and heat endured. The planet, in its brutality, has been the greatest evolutionary engineer ever to exist. There is no wisdom in chaos, but there is a method. It selects the most flexible, those able to transform despair into change. Evolution is the language through which life responds to Earth. When the planet speaks in destruction, life answers in reinvention. Every genetic mutation, every random variation that offers an advantage, is like a new word appearing in a silent dialogue between the living and the environment. Species do not plan or anticipate, they react, and in reacting they create new paths. Thus the planet shapes life, and life in turn reshapes the planet, altering the atmosphere, the soils, the oceans, even the climate. The dialogue is continuous, endless. There is a tragic beauty in this balance. The Earth kills and life gives thanks. The planet destroys and biology responds with innovation. It was chaos that taught wings to fly, eyes to see, and brains to think. Each global crisis sculpted a new form of existence. When oxygen began to poison the primordial seas, life invented the metabolism that would use it as fuel. When forests vanished, animals learned to walk on dry land. Adversity is the mold of evolution. Even today, this mechanism continues. Humanity, by altering the climate and eliminating species, is sowing the ground for future forms of life. The planet will not end with us. It will simply create something new when we are gone. Life always finds a way, even if it must start again from zero. Each extinction opens a new space on the board of existence. It is Earth's method: to destroy in order to recreate, to erase in order to write again. Evolution does not seek perfection, only survival, and survival on Earth demands adaptation to the unpredictable. What we call balance is merely a brief pause between two catastrophes. Life thrives in those intervals, taking advantage of the time the planet grants it before the next change. Thus, natural history advances as a succession of falls and resurgences, where the end is never truly the end, only the beginning of another way of being. The heart of the Earth still beats, but it is not eternal. The internal fire that moves the plates, creates volcanoes, and keeps the magnetic field alive also has an end. Like a living body, the planet loses heat over time. Slowly it cools, and as this energy dissipates, the force that drives its renewal weakens. One day, the geological engine that keeps the world in motion will stop. The Earth will then cease to be a living planet, and will become a silent, cold, and motionless sphere, like so many others that already orbit the Sun. Since its formation, more than 4 billion years ago, the planet has been cooling. In the beginning, it was an ocean of boiling magma, an incandescent hell that formed a thin, unstable crust. The heat came from the collisions that created it, from gravitational compression, and from the energy released by the decay of radioactive elements within. Over the ages, heat has been released into space, and the interior has gradually stabilized. Even today, the core reaches temperatures above 6,000 degrees Celsius, but that fire is slowly fading. Scientists estimate that the planet loses about 100 degrees of internal heat per billion years. That may seem small, but on a geological timescale, it is enough to change everything. When the interior becomes too cold, the mantle stops flowing as strongly. Tectonic plates slow down, and volcanism weakens. Without plate movement, the carbon cycle is interrupted, and the Earth loses its ability to regulate the climate. The surface could become a stagnant landscape, fossilized mountains and motionless seas. The end of tectonism would mark the beginning of a new kind of death. Without volcanoes, there would be no release of vital gases. The atmosphere would thin and the climate would collapse. The magnetic field, dependent on the motion of the liquid core, would begin to weaken. Without it, solar and cosmic radiation would strike the surface directly, destroying the ozone layer and evaporating what remained of the oceans. The Earth, for so long a dynamic planet, would become a mineral desert, much like the Moon or Mars, worlds that were once hot and active, but whose hearts have long gone dark. The process has already begun. The Earth's core is slowly solidifying, and the magnetic field has shown signs of weakening and fluctuation. It is a natural and inevitable phenomenon. In billions of years, the planet will no longer generate enough heat to sustain its internal activity. The fire that shaped the continents and fueled the cycle of life will one day go out, and when that happens, the planet will enter a state of rest, not the rest of destruction, but of exhaustion. Even so, the end of the internal fire will not mark the immediate end of life. Before the interior cools completely, the sun will change first. As it ages, it will grow brighter and hotter, evaporating the oceans and burning the surface. External heat will replace internal heat, but in a merciless way. The Earth's cycle will end surrounded by fire, just as it began. The idea that the planet will one day become geologically dead is uncomfortable, but inevitable. Nothing in the universe is eternal, not even the heart of the Earth. What we now call mountain, ocean, or continent will vanish, replaced by a cold, immutable crust. The beauty of the world lies precisely in its transience. The fact that, for a brief cosmic moment, the planet was able to live, breathe, and create life. We exist within this window of heat, sustained by the energy that flows from the planet's core. When it goes out, the Earth will keep spinning, but in silence. A body among countless others, the memory of a world that once burned, breathed, and dreamed. The map of Earth as we know it is only a phase. The lines dividing oceans and continents are not fixed. They move, bend, and disappear with time. Hundreds of millions of years from now, the planet will be unrecognizable. The Americas, Africa, Eurasia, Oceania, and Antarctica will no longer exist as we know them. The surface of the world will once again unite into a single immense landmass, the next supercontinent. Just as Pangaea once did, this future union of continents will transform the climate, the oceans, and the destiny of life. Geologists call this process the super cycle, the cycle through which continents drift together, merge, and then break apart again over intervals of more than 300 million years. Today, we are in the middle of one of these cycles. The Atlantic is expanding while the Pacific is slowly shrinking. The tectonic plates continue their silent motion, driven by the planet's internal heat. When the Pacific finally disappears, the Americas will collide with Asia, forming a mountain chain so vast it will stretch across the globe. This will mark the birth of the new supercontinent, known by some scientists as Amasia, for the merging of America and Asia into one landmass. Other models suggest a different fate. Perhaps it will be the Atlantic, not the Pacific, that closes first. In that scenario, Africa will collide with Europe, and later with the Americas, creating another giant landmass known as Pangaea Proxima. Whatever the path, the outcome will be the same. All land will unite once again. The planet will do what it has always done: bring everything together, break everything apart, and begin again. The consequences will be profound. The interior of this new supercontinent will be arid and hostile, as humid air masses will not reach so far inland. Heat will accumulate, and vast deserts will spread across its center. Along the edges, tectonic collisions will give rise to colossal volcanoes and earthquakes. Entire oceans will vanish, while others will be born from cracks opening in the Earth's crust. Global climate patterns will shift completely. Ocean currents and winds will find new paths. Earth will reorganize itself once more. Life, too, will change. The species that exist by then, whether descendants of ours or entirely new, will have to adapt to a different planet. Continental isolation will create new evolutionary patterns, just as it did when Pangaea broke apart. New life forms will emerge along fertile coasts, while others will disappear in the barren interior. Biodiversity will rearrange itself, and the planet will enter yet another cycle of destruction and renewal. The next supercontinent will serve as a reminder of Earth's cyclical nature. When it begins to break apart again, new oceans will open, and the story will continue. Each closing and opening of seas redraws life. Each collision creates mountains and erases ecosystems. The planet exists in an endless flow of transformation, where nothing is permanent, only transitional. Modern simulations based on plate movement and the Earth's rotation show that this process is inevitable. But what is most striking is not the destination, it is the rhythm. The planet seems to follow its own pulse, a deep breath lasting hundreds of millions of years. What is now the Atlantic will one day be a plateau. What is now a mountain will become an ocean floor. With each cycle, Earth erases the traces of the last, leaving only fragments in the rocks, a memory that refuses to fade. When the new supercontinent is finally complete, the planet will look entirely different. Days will be longer, as Earth's rotation continues to slow. The tides will weaken. The climate will be extreme, scorching summers and deep winters. The sun, brighter and hotter, will make the environment ever more arid. Meanwhile, the planet's interior, already cooler, will move its plates with increasing slowness. The cycle will repeat, but with a gentler rhythm. like the final beats of a tired heart. And yet, the beauty of this distant future lies in the fact that it confirms the constancy of change. Earth has never been static. It is both memory and motion. Each era is just a breath in its long history. And when Amasia, Pangaea Proxima, or whatever name it takes finally forms, the planet will show once again that destruction is merely another form of creation. Earth has always lived between extremes, but there is a limit beyond which no balance is possible. One day the planet will cease to be blue. The oceans that cover more than 2/3 of its surface will vanish, drop by drop, under a heat that can no longer be contained. It will be the end of the water cycle, and with it, the end of almost all life. This fate will not come from within, but from without, from the sun itself, whose light over the ages grows ever more intense. It is a silent, slow sentence, written in the heart of the star that warms us. The sun, like all stars, changes over time. As it consumes its fuel, it becomes hotter and more luminous. In about 1 billion years, this change will be enough to completely disrupt Earth's thermal balance. Global average temperatures will rise to lethal levels, and the hydrological cycle will begin to break down. The intense heat will cause evaporation to exceed condensation. Clouds will dissipate, and rain will cease to fall. The planet that was once covered in seas and storms will begin to dry out. The humidity in the air will rise, and water vapor, the most powerful of all greenhouse gases, will amplify the warming. It will be a cycle with no return. The more heat, the more evaporation. The more evaporation, the more heat. The oceans will slowly begin to boil, releasing massive clouds of vapor that will rise into the stratosphere, where they will be destroyed by ultraviolet radiation. Water molecules will split into hydrogen and oxygen, and the hydrogen, too light to be retained, will escape into space. Earth will begin to lose its water forever. As the seas retreat, the climate will collapse entirely. Tropical regions will turn into incandescent deserts, and the poles will cease to exist. The air will become thick and suffocating, saturated with vapor and gases. Mountains will erode under acid storms, and the soil will turn into sterile dust. The planet that once held deep oceans and green forests will become a hot, dry, metallic world, with surface temperatures high enough to melt lead. Without oceans, the carbon cycle will also end. Carbon dioxide will no longer be removed by rain and rocks, accumulating instead in the atmosphere. Earth will become a mirror of Venus, a hell shrouded in thick, suffocating clouds where trapped heat can no longer escape. The air will grow heavy. Atmospheric pressure will increase, and no wind, no raindrop, and no trace of green will remain. The blue of the planet will turn into a hazy orange veil. As time passes, the remaining waters will collect near the poles and then disappear entirely. The last oceans will be shallow, boiling lakes beneath a white, blinding sun. The forms of life, long reduced to subterranean microorganisms, will be the final witnesses to the end of the biosphere. And when the last trace of water evaporates, Earth will no longer be a living planet. This scenario, though distant, is inevitable. It is part of the nature of stars and the worlds that orbit them. As the sun ages, it will expand its luminosity until the inner planets become burning deserts. One day it will grow so large that it will engulf Mercury and perhaps Venus, and its light will scorch Earth until nothing remains but a sphere of dry rock. There will be no sudden catastrophe, only a slow, inescapable, absolute process, the same kind that the planet has always used to transform itself. Yet there is something poetic in this end. The cycle that began with fire will end with fire. The water that once gave birth to life will return to the cosmos as vapor and hydrogen, spreading among the stars. The elements that once formed oceans, clouds, and living organisms will drift back into space, ready to create new worlds. The death of Earth will be only another step in the infinite chain of rebirths that define the universe. The day the oceans evaporate will not be the end of the story, only another transition. The planet that has always destroyed and remade itself will cease to exist, but its matter will continue to travel, merging with other stars and planets. The cosmic cycle is greater than Earth's cycle, and in a way the planet will never stop beginning again. It will simply change form as it always has. There will come a day when the planet will no longer breathe. No wind, no sound, no movement. It will be the moment when the last remnant of heat escapes from Earth's interior, and the sun, now transformed into an aged star, will illuminate a lifeless world. The blue of the seas will have vanished. The green of the forests will exist only as petrified memory, and the crust, once alive, will be cold and cracked. The planet that was once full of motion will become an immobile body orbiting the void. It will be the final silence of Earth. Long before that moment, the sun will have completely changed. It will become a red giant, expanding until it reaches the orbit of Venus and perhaps engulfing Earth itself. Even if the planet survives physically, the heat will be unbearable. The atmosphere will evaporate, the minerals will melt, and everything that was once soil and stone will turn into liquid metal. The magnetic field, deprived of energy from the core, will have already vanished. Without this protection, cosmic radiation will pierce through the planet like invisible blades, erasing any biological trace that may still exist. During this process, the crust will slowly vaporize, and the elements that make up the planet, iron, silicon, carbon, oxygen, will be thrown into space. Earth will dissolve into dust, the same dust that once gave birth to the stars. It is a form of return. The planet will not die, it will merely become what it once was, matter scattered through the cosmos, ready to form new worlds. But before that total end, there will be a long period of silence. Even after the disappearance of oceans and forests, the planet will still harbor an almost invisible resistance. Microorganisms buried deep within rocks, perhaps near the residual heat of the mantle, will survive for millions of years after the surface collapses. They will be the last inhabitants of Earth, blind witnesses to a world without sky, without sea, and without future. When the internal heat finally fades, even they will perish. The planet will then fall completely still. The silence will be absolute. No thunder, no waves, no earthquakes. The mountains, fixed and eternally immutable, will stand as monuments without memory. The thinning atmosphere will allow space itself to invade. The weakened sunlight will reflect off a metallic, colorless crust. Everything Earth once was, ocean, forest, desert, home, will exist only within the dust of time. The final extinction of Earth will not be a tragedy, but the natural close of a cycle. Like a flame that dies after giving light, the planet will have fulfilled its purpose. For billions of years, it was the cradle of oceans, continents, and living beings. It was a stage for destruction and rebirth. It was the home of creatures who looked up at the sky and tried to understand their own origin. Earth will not be remembered, but its legacy will live on in every fragment of matter that rejoins the universe. When the sun, now a white dwarf, cools slowly and the solar system sinks into darkness, the story of our planet will be complete. What remains of Earth will drift in silence, perhaps orbiting the luminous corpse of the star that once gave it warmth. No sound will echo, yet the universe will go on. Other stars will be born, other planets will form, and perhaps somewhere far away, another world like ours will begin the cycle anew. Earth has always been the planet that begins again. From its molten beginnings to its frozen ages, from extinctions to renewals, it has always destroyed itself to create anew. But when that cycle ends, one lesson will remain. Life, motion, and transformation are only brief chapters in the eternity of the cosmos. The planet will fall silent, but the universe will continue telling its story in other forms, in other places. Earth existed for billions of years before us. It witnessed oceans being born and vanishing, continents colliding, species emerging and dying. And through all that time, it never needed our presence to continue. But now, for the first time, there is a form of life capable of understanding the planet itself, and at the same time altering it. Us, conscious yet reckless beings, fragile before time yet powerful before the environment. The question that remains is inevitable. Are we a natural part of Earth's cycle, or an interruption within it? For most of its history, the forces that changed the planet were geological: fire, ice, impact, and time. Today, it is us. In just a few centuries, we have altered the climate, changed the chemical composition of the atmosphere, and reshaped entire landscapes. We have cut down forests, dammed rivers, extinguished species, and spread metals and plastics across every ecosystem. What once took millions of years now happens in mere decades. We have created a new kind of geological event, a conscious cataclysm, made by a species that knows what it is doing, yet continues anyway. Some scientists call this new age the Anthropocene, the age of humanity as a planetary force, a moment in which we ceased to be merely part of the environment and became agents of transformation comparable to volcanoes and ice ages. It is a title both frightening and symbolic. For the first time, a living species has become the primary driver of planetary change, but unlike natural forces, our impact is chaotic and fast, and the planet, which always had time to regenerate, now finds itself without a moment to breathe. Global warming is only one expression of this imbalance. The excess carbon dioxide we have released in just over a century is altering the climate in ways similar to great eruptions of the past, but at dozens of times the speed. The polar caps melt, the oceans warm, the currents shift. We are, in a sense, recreating the conditions of ancient mass extinctions, yet fully aware of what we are doing. The planet does not rebel. It merely responds, as it always has, with heat, storms, and instability. Still, there is a deep paradox in this. Earth created us, and now, through us, it transforms itself. Perhaps we are not a mistake, but its newest mechanism of renewal. We are the direct result of evolution, a natural consequence of billions of years of adaptation and selection. Human intelligence, then, is the Earth thinking about itself. And if that is true, we are not an interruption, but a new phase in the same cycle, the conscious phase. But consciousness brings responsibility. Unlike blind natural forces, we can choose. We can accelerate destruction or strive to balance it. We can align ourselves with the planet's rhythm or fight against it until collapse. We are the first species capable of deciding whether the cycle will continue with us or without us. And paradoxically, it is that freedom that makes us fragile. Perhaps we are only a brief anomaly, a flash of self-awareness soon erased by the very planet that created us. Or perhaps we are the beginning of a new kind of continuity, one in which life, through intelligence, learns to preserve the balance that gave it birth. In either case, Earth will continue. With or without humans, the cycle will go on, as it always has. When the last trace of our civilization fades, the planet will rebuild itself. Ruins will be buried in dust, metals will oxidize, and time will erase our footprints. And one day perhaps another form of life will emerge, maybe made of silicon, maybe of carbon, maybe of something beyond imagination. It will look around and ask, as we once did, where did we come from? Without knowing that the answer was written billions of years ago, Earth always begins again. We are only one of its many beginnings, and if we disappear, it will be just another page turned in the infinite book of geology. The difference is that, for the first time, a page knows it is being written. Earth has memory, not a living memory made of words or recollections, but a mineral one, silent and deep. Every layer of rock is a page written with pressure, heat, and time. Every fossil is a surviving sentence of a language the planet speaks slowly. Even after erasing almost everything, Earth keeps traces, fragments of ancient worlds buried beneath its crust. The planet forgets almost everything it creates, but never completely. It records in silence the passage of what once existed. When we look at a mountain cut by a river, or at cliffs revealing colorful rock layers, we are, in fact, seeing the planet's history laid open before us. Every color, every texture, every fold tells part of the life that once was. Coal, for example, is the remnant of tropical forests that existed hundreds of millions of years ago. Limestone holds shells and skeletons of marine organisms from seas that no longer exist. Even petroleum is a form of memory, the result of decomposed beings that lived in ancient oceans and whose molecules now power our civilization. Earth speaks to us all the time, but few still know how to listen. Fossils are its clearest words. Created by the coincidence of death and preservation, they capture the moment when something living becomes part of the mineral world. An organism dies, is buried by sediments, and little by little, its parts are replaced by minerals, transforming what was flesh into stone. It is a slow, almost poetic process, where time erases the fleeting and eternalizes detail. The contour of a leaf, the bone of an animal, the footprint of a creature crossing the mud, all become documents. But the planet is not a careful archivist. Of all that has ever lived on Earth, less than 1/10 of 1% has been fossilized. The vast majority vanished without a trace. That means the history we know is only a shadow. a faint echo of a reality infinitely richer. Yet these fragments are enough for us to reconstruct the past, to understand how eras overlapped, how species appeared and vanished, how climates changed and oceans shifted. To read Earth is to decipher time. Sedimentary rocks are the great books of this memory. They form in layers, stacking stories one atop another. The oldest lie deep below, crushed and hidden, while the most recent are exposed to light. In some places, these layers reveal discontinuities, gaps known as geological hiatuses, periods when Earth erased part of itself. They are like torn-out pages of a book, reminding us that the planet's memory is fragmented and imperfect. There are also memories recorded in microscopic minerals, like zircon crystals, which preserve in their atomic structures the marks of heat and radiation from billions of years ago. Some of these crystals are over 4 billion years old and are the oldest solid objects known on Earth. They are the memory grains of the planet's infancy, particles that have survived everything. Earth's fossil memory is not just a record, it is a testimony of transformation. Each layer preserving yesterday's life is built upon yesterday's death. Every fossil we find represents a moment when the planet destroyed something and at the same time kept it. Earth does not archive to remember, but to continue. It has no nostalgia, only process, and yet there is something deeply human in looking at a fossil and recognizing a kind of mirror within it, because we too are part of this memory. When we disappear, our buildings, our bones, our artifacts will become mineral traces mixed with rock, ash, and dust. The planet will record us as it did the dinosaurs, the trilobites, and the first algae. We will be just another line in geology. The memory of Earth is cold but fair. It keeps what matters, the evidence that everything changes and that life, in all its forms, is only a brief spark upon a stage of stone. With every layer, the planet writes and rewrites its history, without haste, without emotion. And in the end, what survives is not the name, but the testimony that something once existed. Earth has never known an end. What we call destruction is merely an interval, a transition, a new beginning disguised as collapse. Everything that has ever ended on this planet has turned into something else. Every mountain destroyed became sand. Every burned forest became fertile soil. Every extinct species made room for another to flourish. The planet does not die. It changes, and it is precisely this infinite ability to renew itself that makes Earth unique in the cosmos, a machine of restarts where the end is nothing but illusion. From the very first moment, the world's history has been made of cycles. Fire formed rock, ice shattered rock, and melted rock returned to fire. Life appeared, multiplied, vanished, and was reborn in new forms. The atmosphere has changed countless times. It has been poisonous, frozen, and burning. Yet through it all, Earth persisted. Everything that once seemed final turned out to be only a temporary state. The planet is like an infinite breath, expanding and contracting in a rhythm so slow that we, fragile and hurried, can barely perceive it. Perhaps that is why humans fear the end so much. We live in short spans, and our gaze reaches only the immediate. But the planet thinks in scales beyond us. What is tragedy to us is mere motion to it. When one era ends, another begins. When one species disappears, others rise upon its ruins. The planet does not mourn what it loses. It simply continues. Life, contrary to what we imagine, is not a permanent gift, but a state that arises whenever conditions allow it. Earth does not keep the past. It recycles it. Even the most devastating moments, the global ice, the asteroid impact, the end of the Permian, were only adjustments in balance. Destruction is the mechanism that keeps the planet alive. If nothing changed, if everything stayed the same, Earth would die. Movement is the essence of its existence. In every era, it reinvents itself, and we are only one of its fleeting versions. When we vanish, another form will come, molded from the ashes of what we were. The myth of the end is, in truth, a human myth. The universe does not deal in endings, only in transformations. Stars die, but their material creates new stars. Planets fade, but their dust forms new worlds. Death on a cosmic scale is merely the redistribution of matter and energy. Nothing truly ends. Everything simply changes state. The body we have, the air we breathe, the soil beneath our feet, all of it has been something else in another time. Eternity does not lie in permanence but in change. Earth is a constant reminder of this. It has destroyed and remade itself for billions of years, and will continue doing so until its final thermal breath. When the inner fire goes out, when the oceans evaporate, when the sun expands and consumes what remains, even then, the atoms of the planet will keep traveling through space, and somewhere far away they may come together again, to give rise to another world, another chance, another form of life. History never ends. It only changes stage. To understand this is to realize that Earth is not just a place but a process. It is the continuous act of transforming what exists into something new. The true miracle of the planet is not life itself, but its capacity to create the conditions for life to emerge again, even after it has been erased. Destruction is part of creation, and the end is merely the moment when the old gives way to what has not yet been born. The cycle of the world is therefore the cycle of everything, from rock to being, from being to dust, and from dust back to rock. Nothing is lost. Everything transforms. Earth does not fear the end because it has never known it. And perhaps that is the deepest lesson of all. There is no end, only change. And in the silence of time, every transformation is a new form of life breathing within the same eternal universe. Earth has always begun again. From the first instant of fire to the last breath of silence, it has never ceased to transform. Everything that exists today, the mountains, the seas, the air, and even us, is the result of billions of cycles of destruction and rebirth. We are part of a planet that has never accepted stillness, that makes chaos its balance and change its destiny. And when we understand this, we also realize that the beauty of the world lies not in permanence, but in impermanence. Nothing lasts forever, and that is precisely what makes everything so precious. To look at the sky and realize that every star, every grain of dust, and every living cell are part of the same process is to accept that we are made of Earth itself. The iron in our blood once flowed through the planet's molten core. The calcium in our bones came from ancient seas. The oxygen we breathe was born from forests that no longer exist. We are the living memory of past ages, the continuation of the worlds that Earth has created and destroyed. We are the planet thinking, feeling, and trying to understand itself for a brief instant of consciousness. Earth does not speak, but it teaches. It teaches that every destruction is also a beginning, that every loss carries within it the seed of rebirth. It teaches that life is resistance and reinvention, and that time has no haste, only direction. Everything that seems like an ending is in truth a passage, and we, by existing here and now, are witnesses to the infinite motion that makes the planet what it is, a machine that transforms nothing into everything. Perhaps humanity's greatest privilege is being able to observe its own home in transformation, to watch the sea move, the mountain erode, the wind change direction, and recognize a pattern within the chaos. Earth is not merely the place where we live, it is the process of which we are a part. We are inside it, like cells of the same organism, breathing together, pulsing in the same rhythm. So, before you sleep, take a deep breath. Feel the pull of gravity that anchors you to this ground, the same ground that was once lava, ocean, and desert. Feel the air that has passed through millions of lungs before reaching you. Realize that every atom in your body was once part of another form, another time, another story. Nothing we are is new. Everything is continuity. Earth will continue its journey, as it always has. And we, when we depart, will continue with it, dissolved into its minerals, its waters, and its ashes. Eternity does not lie in lasting, but in belonging. If this video brought you calm, reflection, or curiosity, support this channel. Leave your like, subscribe, and share it with someone who also loves to learn about the universe while resting. Write in the comments where you're watching this from. Sweet dreams, and see you in the next video.